Hi, I'm Justin Ely, and this is my attrition case study for Key Energy Services. So let's get after it. So the data had 1,470 records, did not find any missing values. There was one response variable that is binary, that's attrition. There were 1,233 no's and 237 yeses. I'm a big fan of variable or feature reduction. I do use those terms interchangeably. Employee count, every single field was populated with a number one. Over 18, everything was a yes. Standard hours, everything was an 80. Potentially, we would remove the employee number field or feature, mainly because it looks like it's just a foreign key. It doesn't really have any significance on determining employee attrition. So that left us with 32 explanatory variables. I would like to point out that two of those were highly correlated, monthly income and job level at 95%. At 95% correlation, they're nearly telling us the exact same level of data. There's not much difference between them. But I went ahead and left them in for this exercise. But in production, we'd probably put our heads together and figure out if that, which one we want to use because we don't necessarily need them both. The next thing I wanted to do was figure out from a high level which features were really driving if we were able to determine if an employee was going to leave a company or not. So to do that, I used a logistic regression model. I did a 70-30 train test split. So I took 70% of the data and used that to teach the model or train it, 30% to fed into the model, and the model was accurately able to guess if an employee was going to leave the company 88% of the time. And I felt that that was a really good accuracy score. If you wanted to, so the model spits off coefficients, which are like weights. The higher the coefficient, the more important that feature is to the model. So, which allows us to rank them. So, in this case, overtime was the most important, years at the company, second most important, years since last promotion, and so on down to education, which was the least most important. And just to kind of further explain the coefficients, if you think about y equals mx plus b from back in math class, in this case, attrition would be your y, a would be your b, that's your intercept. And the rest of it is just, like the mx just expanded. So 0.88 times the overtime value, 0.53 times years at the company, and you just follow it on down the line. And that's, it's a pretty basic concept to develop the formula. One thing I would like to point out is this was done at a high level, at just the feature level. If I wanted to go in and actually determine the levels of the features, so for example, overtime yes or no, or how many years at the company, I would have to one hot encode each one of those different levels and refeed it through the formula. But Power BI actually does that for us, which is nice, and it came up with a slightly different ranking order. So in this case, age being 21 or less was the number one driving factor. Somebody that's 21 or less is 3.6 more times more likely to leave a company than the average employee, which is at 15%. Total working years being at 2 or less, they're 3.2 times more likely to leave the company. Over time, being a yes, they're almost 3 times as likely, and so on and so forth. Power BI also does a great job of building us some segments and saying, hey, these are the combinations of variables to where you're probably going to have your most attrition. Number one, segment number one is job level less or equal to one being the lowest. Overtime, yes, and stock option level is 0. So people that meet this criteria are roughly 67% more likely to leave a company, which is 51 percentage points higher than the average of 16.1%. The next segment is very similar. Job levels of 1, overtime's a yes, but this person or this group of people have stock options. And they're roughly 40% likely to leave a company, which is 23 points higher than the average. So I put this all together and I juxtapose my logistic regression, which just takes a high level look at the features with their coefficients. And then I took a look at the Power BI, which actually dove into the different levels of the features and what it says the attrition increases would be. And you can see here where overtime was my overall. Overtime, yes, was Power BI's number 2. Years, at the company was my number 2. Years at the company was Power BI's number 4. Monthly income was my number 7. It was their number 5, so on and so forth. Marital status rounded out number 10 for both of us, but it dove a little deeper and said it's actually single people that you should be more concerned about. In terms of the segments, I reviewed segment 1 and 2. Segment 3 really focused more on people in sales. Segment 4 focused on people that just haven't been at the company that long, so less than 2 years. And segment 5 is really more mid-level folks, been there more than 2 years, or been working, I should say, more than 2 years. They're just not satisfied with their job, or maybe they're stuck in a rut. So who's at the risk of attrition? To summarize it, low-level employees that earn overtime may or may not have stock options. Sales executives, and then mid-level in terms of working years, employees that have low job satisfaction and do not earn overtime. So overtime does seem to keep popping up in here. And really those were my findings in a nutshell. I did include the EDA here. This was really just to look at variable distributions. It does have a toggle so you can turn on, attrition yes, attrition no, or just look at the data in general. I also took a look at income versus job role. Was really using box plots to look for the outliers. Nothing really stood out to me here. And then looking at age, I really wanted to make sure that we didn't have teenagers making, $20,000 a year. I would question that data. These outliers here, based on the ages, I'm guessing these are probably salespeople. And this one over here is probably a senior executive or the CEO, he or she self. So that is what I have. Happy to answer any questions. Again, I'm Justin Ely, and this was my attrition case study. Thank you for your time.